All right, YouTubers, let's talk about graphing. No, let's not talk about graphing. Let's talk about solving, rather, rational functions. The first thing on number one, if you have the same common denominator, we can multiply by that common denominator. So when you do that, it cancels out all the different denominators. So then I get x plus 1 plus x minus 1 equals 4. Combine like terms, 1 and negative 1 go away, I get 4, divide by 2, and x is 2. When you have common denominator, it's super easy. When you don't have the common denominator, it might be a little more challenging. But if you just have one term on each side, you can just cross multiply. So you get 3 times y plus 1 equals 5 times y minus 5. Then we're going to hippity-hoppity distributive property 2 times. So I get 3y plus 3 equals 5y minus 25. And then we're just doing the whole baby to the mama thing. We subtract 3y from both sides. So I get 3 equals 2y minus 25. And I'm adding 25 to both sides. And I get 28 equals 2y divided by 2. And y is 14. Okay, so if you have two terms, one on each side of the equal sign, cross multiply. If you have a common denominator, like on number 1, just multiply by that common denominator. But if you have 3 different denominators, then you're going to have to multiply by all 3 of them. So 2, x minus 1, and x plus 2. We basically just pick whatever's in the denominator without repeating and just multiply by all of them. So all this is going on the top here, top here, top there. So write small. Oops, just 2. All right, then we can see what's going to cancel out. Because remember, we're trying to get rid of all the denominators. So x minus 1 goes away. Yep, x plus 2, and then the 2's. So now I'm left with 2, and then x plus 2. That's a distribution problem. 2 times x minus 1, also distribution. And then we have a binomial times a binomial, which means we're either going to be box methoding, or foiling, or double distribution, or whatever you want to call it. So we distribute. 2x plus 4, 2x minus 2. Do that. I'll show my work here. So I get x squared, 2x, negative x, and negative 2. Combine our diagonals. So that gives me x squared plus x minus 2. And then we're just bringing baby to mom and all that stuff. So combine 2x, combine 4, negative 2. So it gives me 4x plus 2 equals x squared plus x minus 2. Bring all this junk over here. So subtract 4x, subtract 2, subtract 4x, subtract 2. So x squared minus 3x minus 4. And then the last step, I know you're getting tired of writing, is we're factoring this. So what times what is going to make negative 4, but also add up to negative 3. And that's going to be positive 1, negative 4. Then we're going to set each part equals 0, so x plus 1 equals 0, x minus 4 equals 0. Move this on the side, move that to the other side, I get x equals negative 1, and x equals positive 4. Now the last thing that we need to do is we need to double check. So discount double check here. We're going to take negative 1, put it in for the x here and there, and if it gives me 0 either way, then it doesn't work. Well, negative 1 minus 1 is negative 2. That's cool. Negative 1 and 2 make 1. That's cool. If I take 4, put it into both of those, I get 3 and 6. That doesn't give me 0, so both of them work. If one of them does not work, then it's not a solution. So if negative 1 gave me 0 on the bottom, I would cancel that out, and it would just be 4. All right? Go ahead and pause it, and I'm going to show you the answer to number 4. So here's your chance to pause it. Boom. All right, let's find number 4. Here's number 4. So we multiplied by 6 and x minus 2. We did all of our canceling out here. You can see in blue and green. I did my distribution here, combined like terms, factored it, and then you can see here I got 2 answers, 2 and 2/5, but I took 2 and put it in right there, and right there that gives me 0, so that means 2 does not work. 2/5 is my only solution. Okay. All right, let's go to number 5, and we'll probably do one more on the front, and we'll skip to the back. So number 5, we need to factor the right-hand side. So 4 on top, of course. And then what times what makes negative 3 adds up to 2. So that's going to be x plus 3, x minus 1. And so on the left-hand side, I got that, and I get that. All right, so this one, I got a couple things that match. So I only need to name them once. So I'm multiplying by everything by x minus 3 and x minus 1. So when I do that, maybe you're good at this in your head now. This is going on top here, there, and there. So if you can do this in your head, awesome. You can skip this step. But if you see here, the x plus 3's cancel out, and you just have x minus 1. On this one, we have x plus 3, x minus 1 over x minus 1. The x minus 1's cancel. So now you got x plus 3. And on this one, you get 4, and then everything. And everything is going to cancel other than the 4. So you just get 4. And this one's super duper easy. You get 2x plus 2 equals 4. Solve that for x. That's an Algebra 1, 7th, 8th grade problem probably. Subtract 2, you get 2x equals 2, divide by 2, and x is 1. So we take 1 and, oh no. If we plug 1 in, it doesn't work. It gives me 0. If nothing works, that means no solution. Let's do one more, number 7. How about you try number 7 and we'll take a look at the answer. Here's your chance to pause. Let's go find number 7. There's number 7. Kind of a long problem. The only answer is 7 because if we take that negative 2 and plug it in, we don't get it to work. So we factored this, and then I multiplied by that, b plus 3, b plus 2. So the only thing left here is 3. Then I have a binomial, b minus 1, b plus 3. And on the right-hand side, I have 7 and b plus 2 because the b plus 3's cancel out. So I distribute here. I'll erase some of my arrows. It's a little confusing there. There we go. My 3 and my negative 3 cancel out after I FOIL or box method. That's what we're doing here. Then I move 7b over, move 14 over. I get this guy, b squared minus 5b minus 14. Then I factor that. And I get b plus 2, b minus 7. Then I set each part equal to 0. So I get 2 and negative 7. But as you can see, obviously we take negative 2 and put it in. If I take negative 2 and put it in right there, I get 0. Anything over 0 is undefined. So that does not work. I try 7. 7 works, 7 works, 7 works. So those are my answers. Now we can also use the calculator to help us out. And that's going to be the back. Now if you put, on number 9, if you put this equation into y1, this equation into y2, we can use the table and the graph to help us figure out where the equation is, or where the answers are, excuse me. So there's my y1, there's my y2. Notice how I have parentheses. We need to be sure we include those. So then I go to my graph and I see, obviously, they intersected there and there. I can't really tell exactly where they intersect, so I'm going to go to my table. So then I look, remember one of them was negative, right? Negative 3, comma negative 2, so that's one of my answers. So for the one of them, I'm going to have negative 3, and then, I forget, yeah, negative 2, negative 3, and negative 2. Now this table was here to do it by hand. We're not going to do it by hand. So they want you to do like all these and do all that stuff. We don't need that. We don't need the middle table to compute it all. And so we don't really need all that. Our other answer was 3, 1. So 3, 1, 3, 1. Those are my answers. That's all you got to have right there is negative 3 and positive 3. Those are my answers. All right. Number 10 works the exact same way. Let me see if I can find the answers for that one. Go ahead and pause it. And then number 10, the answers are negative 3 and positive 1. So number 10 is negative 3 and positive 1. They intersect at negative 3, negative 1, and they intersect at 1, 1. All right. Happy computing. Catch you later.
In the middle.